All right, you should have this handout for antiderivatives and slope fields. Um, don't you love this picture? This is my favorite picture of all the um, PowerPoint slides. I really like the slope fields. So first, just to kind of give a little bit of a review, remember if we have y equals x squared plus 3, then you know that y prime equals 2x. You all know that. And we also know that if y is x squared minus 5, y prime is also 2x. So when there's a constant, we get the same derivative when it just differs by a constant. So it doesn't matter whether the constant was 3 or negative 5, because when we take the derivative, the constant disappears. So when we try to reverse the operation, when we are doing antiderivatives, and if you knew that y prime equals 2x and you needed to find y, then remember we would have x squared plus some constant. We don't know what that constant is. So anytime we don't know that, we put a c to represent that there might have been a constant. Now, if we have some more information, then we can actually find the value of c. So if you are given, and this is what some of your problems will look like in this section. So if you're given y prime equals 2x, and then you're also told that y equals 4 when x equals 1, and you're asked to find the equation for y. You start by finding the antiderivative, y equals x squared plus c, and then you substitute in the values you were given. So we're going to substitute in a 4 for y and a 1 for x, and then you can actually solve for c, and you would find that. So we get y equals x squared plus 3. This is actually called an initial value problem, and you have to be given the initial values in order to find the constant. An equation containing a derivative is called a differential equation. So that's actually the name. Anytime you have an equation that contains a derivative, it's called a differential equation. So we've actually already dealt with some of those. It becomes an initial value problem when you are given the initial condition and asked to find the original equation. So you will be asked to do initial value problems, but then be aware that you're going to be given that initial condition in order to do so. So initial value problems in differential equations can be illustrated with what is called a slope field. And this is what you would be doing. Usually in a slope field, you are using a computer or graphing calculator, but we have recently had AP tests where you were asked to draw a simple slope field by hand. So because you're not going to be asked to use technology on the AP exam to do a slope field, if it's on the exam, it would be by hand, and it's going to be a pretty simple one. So we're going to stick to some pretty simple ones in our course. So suppose you're given y prime equals 2x. What you're going to do is you're going to pick different values for x and y. A good one to start with is 0, 0. So you substitute into your equation, x is 0 and y is 0, and notice there's no place to put the y. There's no y in our differential equation. So you're just going to substitute the 0 in for x. 2 times 0 is 0. So at the point 0, 0, my slope is 0. So then you're going to draw a segment that goes through the point 0, 0 with a slope of 0. Then you go to a different point. So if you used the point 0, 1, so if x is 0 and y is 1, then if you plug the values into your equation, again, there's no place to plug the y. 2 times 0 is 0. So then at that point 0, 1, you would have a segment with a slope of 0. Now when you continue that, like if the point 0, 2, since it's only the x that determines for this problem, you're going to get zeros all along the y-axis. So if you would continue that, you would see, I'm not going to go through explaining each one, but you can see along the y-axis that you get slopes of 0 all along the way. So what happens when x equals 1? So check out the point 1, 0 and see what happens. So if you plug in a 1 for x and a 0 for y, again, it's just determined by the x. 2 times 1 is 2. So you get a slope of 2, and you're just going to kind of approximate. A slope of 1 would be like at a 45-degree angle, so this should be a little steeper than that. You're just going to kind of approximate when you go through. If you plug in the points 1, 1, you get a slope of 2, because on this vertical line here, when x equals 1, you're always going to get a 2 for the slope when you plug it in. Then you would do the same thing, letting x equal 2. And you're going to see that you get a slope of 4, so you draw it a little steeper. You make it steeper than what you drew before, so that in relation to the other ones, you can kind of start to see what's happening. Then if you go to -1, you're going to get a slope of -2. So it should be the same steepness as what we saw on this side. It should be the same steepness, except we're going to be going a negative direction instead. So we have a negative slope. And then if you plug in a -2, you'll have -4. So you would have this. Okay, so now the reason this is called a slope field is literally you are creating a field of slopes. And notice the shape to that. You can kind of even see a parabola shape, which shouldn't surprise us because we know the antiderivative of this is going to be a parabola, but we don't know where to draw it unless we're given an initial value. So if you're given a condition such as the point 1, -2 is an initial value, you would find the point 1, -2, which would be, about right here. So you would have a point about at that spot. And then from that spot, just kind of follow the pattern, follow the curve. And here you get a picture of this parabola that would satisfy this initial condition. So I kind of think of it as like the current. If you think about, where you might start, and then think about if it was a current and it was, it was a boat and it was pushing it along, that you can kind of trace out what the graph would be to get an approximate graph of the function if you have the slope field and an initial value. By following the slope field, you get that rough picture of what the curve looks like. And of course, we see it's a parabola. Integrals such as the integral from 1 to 4 x squared dx are called definite integrals. We've dealt with those before because we can find a definite value for the answer. So for example, you take the antiderivative, and we already have learned that the constant's going to cancel, so we don't usually show that with the constant. If you plug in a 4 and you plug in the 1, and then when you subtract, you see the constants are going to cancel out. And so we always leave them out when we do definite integrals. However, what we're going to look at now are called indefinite integrals. Notice the difference. There are no limits. There's no limits of integration on this. That's when it's an indefinite integral. And we can't find the definite value for the answer, which is why it's called indefinite. So when you have an integral like this that does not have the limits of integration, then you're going to find the antiderivative, but you have to remember to put plus a constant. So anytime you are finding an indefinite integral, you always have to include plus a constant. So I'm going to be doing another video of some examples from our textbook.